All right. On this first one here, our ln of 2x plus 6 equals 5. What can we do to try and solve this? Put it in exponential form. What are we going to get when we put this into exponential form? E to the 5th equals our 2x plus 6. So switching this around from our logarithmic form, log base e, that's what ln is, back to our exponential form. So we're solving, trying to get our x by itself. What do we need to do? Minus 6 from both sides. So we're going to have our e to the 5th minus 6 equals 2x. How do I get x by itself? Divide by 2. So we're going to have our e to the 5th minus 6 over 2 equals x. If you need a decimal answer, you can type it in the calculator, but you do not need to. This is our most exact answer. How about the next one? Yeah. This one is our base of 2, our power of negative 1 equals 3x. What is 2 to the negative 1? 1/2. So this is 1/2 equals 3x. So what does x equal? 1/6. Divide both sides by 3, we get 1/6 equals x. So sometimes we get nice tidy things, sometimes we get super gross things like the left-hand side. So that's very much like what we did yesterday. We have one more kind of problem that's in that 5.6 homework that we haven't really worked on much. And that's when we have some condensing in it. I know they're long. This is 2 separate problems. Right there. That's where it divides. So we have logs on both sides, which are kind of icky. So our left-hand one, we have log base 4 of 2x plus log base 4 of 5 equals log base 4 of the quantity x plus 1. So I see that all these logs on this first problem have the same base, which is great. We love that. So I'd really like it if I had the log of something equals log of something, because then we're just looking at our arguments. So is there a way that I could take this left-hand side and shrink it down to be a single logarithm? Yeah. Between our logarithms, if we have addition between them, I can multiply my arguments, which I need a different color here. This is our condensing laws. So this becomes, I'm going to do it in 2 lines here just so we see it, log base 4 of 2x times 5, which is the same thing as log base 4 of 10x equals our log base 4 of x minus 1. Now what can we do? I want to know when this chunk is the same as this chunk. My 10x equals my x minus 1. So I can just put those 2 pieces next to each other in our equation. 10x equals x minus 1. I want to know when those 2 arguments are the same. So what can I do? subtract x. So it's going to give me 9x equals -1. So what does x equal? -1/9. Let's do a very similar thing on the right-hand one. So we have log base 7 of 6x equals log base 7 of 9 plus log base 7 of x minus 4. Very similar vibe. But what pieces are we going to put together? How can I condense this down to be a single logarithm? Yeah, I need to take my 9, our addition becomes multiplication, and our x minus 4. So this is going to become our log base 7 of 9 times our x minus 4. Equals our log base 7 of 6x. So we've got to condense it down so we have just a single logarithm. Once we have a single logarithm, I can look at my arguments and see when those equal each other. So we want to know, when does 6x equal 9 times x minus 4, also known as 9x minus 36. What do we do next? Yeah, minus the 9x. We get our negative 3x equals negative 36. So what does our x equal? 12. So sometimes we'll need to condense first. There's one piece that we need to do that I didn't on the first one, because I wanted to wait till we had a second one to look at. We need to make sure that we still get a valid answer. I cannot have negative bases, and I can't have negative arguments. So if my x is 12 on this one, and my bases are all 7, so the bases are good. Are any of my arguments going to be negative? No, so this one's good. What about on the left-hand one, when we have our -1/9? Do we have an argument that's going to be negative? In fact, I have 2 arguments that are going to be negative. So this is that we have no solution here. There is no valid solution. Which is why I didn't talk about it right after this one. I didn't want to have that be our first answer. Cannot have. It does apply to these. I was just waiting until we had a valid one, because I don't like that I put that one first, because I'm mean like that. I don't know, probably what it was is I was writing them late at night and wasn't paying attention to that. So we cannot have a negative base, so we have no solution here. Except that's not the base, that's the argument, because my brain is not wanting to work. Negative argument. I mean, we can't have a negative base either, but we can't have a negative argument. Okay, we're going to practice a couple more. So we'll do 2 more, and then we'll have the rest of the time to like work and ask questions and stuff, okay? So we have 2 log base 4 of x equals 3. And there's a couple of different options on this one. Depends on how comfortable we are with fractions. What should we do first on this one? Valid. We can absolutely divide by 2. So it's going to give us log base 4 of x equals 3 halves. Then what? 4 to the 3 halves equals x. What is 4 to the 3 halves? 8. Square root of 4, that's what the bottom piece, our index, is 2. 2 cubed gives us 8. You can also type it in the calculator. But imagine if we didn't have calculators, so just be thankful for that. You could also take this 2 up and make it be a power. So we have x squared. 4 cubed equals x squared, and solve it that way, remembering that we can't have negative arguments. So our x is 8. The one on the right is probably the most annoying, because I've got some logs and I have some not logs. So we have log base 2 of 2x minus 6 equals 3 plus log base 2 of x. What could we do over here? This is our last one, by the way. Yes, I want to get my logs together. So I'm going to subtract this guy, leaving the 3 alone. So we're going to have our log base 2 of 2x minus 6 minus our log base 2 of x equals 3. Why does that help? Now I can condense this. I can switch this out into a single log. When I have subtraction between, what does that mean is going to happen? Division. So this is going to become our log base 2 of the fraction 2x minus 6 over x. That equals 3. Now what can I do? Switch this out of log form. 2 cubed equals our whole argument, that fraction, our 2x minus 6 over x. What is 2 cubed? 8. So I have that 8 equals 2x minus 6 over x. What can we do here? Multiply by x on both sides. I want that x out of the denominator. So we're going to have 8x equals 2x minus 6. And we're almost there. What next? Gives me 6x equals negative 6. So what does x equal? -1. Okay, so sometimes we're going to have to use our condensing rule. Sometimes we'll have to do a little expanding. But we have all kinds of pieces that we can use. Is that a valid solution, though?
No.
Why? Because we have a negative argument. So this actually ends up with a no solution. Because of this x right there. Okay. So there's a couple in 5-6 that are like that on the homework. I'm just going to flip through the 5-6 homework again, just to double check that we covered all the things. Boop. Okay, there's a couple of like weird story problem things, but it's honestly, I think you can do it. But other than that, you should be all right, okay? So we have a chapter test on Thursday. There is a typo in the review if you picked it up yesterday. On some of them it was fixed because I printed in 2 batches. On some of them it's not. So check question 6G. It should have a 4 to the x, not 4x. So it's the x is an exponent. It just mistyped. So 6G, it should be 4 to the x. But other than that, it should be good. I have the answer key made. I will get it posted today. But that was just one of the things I noticed. So you guys have the rest of the day to work on it. If you need a copy of the review, they're up on the grade table right by the screen. You said the restroom? Oh, yeah. Okay, so if you got questions, do that. If you want to work on the homework, totally fine. Yeah, just do the thing. Get yourself ready for the test on Thursday. But that's the entirety of that chapter.